Okay, so we're going to look at the Java compiler, which is a very critical part of our workflows for many of us. So it's good to understand what's going on. What you'll see here in this visualization is three kind of main clusters that we'll go through and explore in a little more detail. Uh, I'm a big compilers nerd, so I love learning more about compilers. And what's really exciting to me is this source package over here. The cool thing about this is that you have this source tree, and in a compiler, what happens is that we start with a uh, text file, and then we convert it into what's known as an abstract syntax tree, or AST, which basically is an in-memory representation of that source code. The nodes in that tree are the different syntactical elements of a Java program. So let's take a look at this here. What's really cool here is that you can see the different syntactical elements. One example of this is array access. So in array access, you can see in this Java doc, you have an expression which represents an array, and you're indexing into it using using the square brackets. That's something that's allowed by the language, and you have a representation of that here. What's interesting is that this is an interface, not a class, and so there's no way to know how it's actually stored in memory, but this is how it's represented semantically in our program, right? In this case, in an array access, you have to have an expression and you have to have an index. That's the number that you're indexing into the array, right? You have other things such as an assignment, right? Over here, you have a variable equals an expression. This is a representation of that type of assignment. And so you have the two parts, the variable and the expression. You can go through all of these different types of syntactical elements, and they're all enumerated here. That's really cool because, in this sense, this entire package over here is it's kind of a specification for the entire Java language. Another interesting thing is that you see in these Java docs, this comment above the class or interface, you have a little bit of syntax there too, like the @author or @since. That itself is kind of a mini language, and so it has its own corresponding abstract syntax tree, which we can look at in this doc tree over here. And so we had, like, for example, @author. Well, that's what's represented by the author tree, and it has the actual name as a piece of data. Again, it's an interface. We saw, for example, since, right? That's also here, and it has the actual what's the expression that follows @since here. Okay, so that's one cluster over there, right? And then we have another cluster over here, which is these tools. Look at it here. And we have things like Java H and Java P. These are command line tools. Java H is for generating header files for native extensions, and Java P is for looking at the class files that are generated as part of the compilation. These are kind of minor tools, and as a result, they show up in this visualization as part of this tools cluster. On the other hand, you have one of these tools, which is the javac, the actual compiler itself, which we'll take a look at. But what's interesting is that that's forming its own cluster because it's so important in this distribution. So looking at this cluster, you can see that there's a whole bunch of different parts to it. You would see this in a file explorer too, but here you can see the kind of relative complexity of the different parts of it. For example, you have the processing cluster over here. It's a package that represents annotations processing, right? So you have the @something that annotates a class or something like that. This processes those types of annotations. So that's an interesting part of it. But the really interesting part for me is this parser over here. And take a look at this. You have, for example, the tokenizer. This takes different characters in the source file and turns them into groups of characters that represent some element of the language, for example, string or an identifier and so on. And then those tokens are then taken by the javac parser and turned into an abstract syntax tree, right? In this package over here that we're looking at, really the parser is the most complicated one in terms of the number of methods. And so that's probably one of the most important things that you'll want to look at. And it makes sense, right? A Java parser will be a big part of how the compilation happens. In the parser, you can see a lot of different flags for features that can be enabled and disabled. So there's a lot of complexity there. You can also see the different pieces of the parser, the ability to look at a token that's upcoming, the ability to report a syntax error, and just basically do the bookkeeping necessary to look at the source code and turn it into a tree. Right. We also have the main over here. Right. Pull this out closer. Here we have a couple of different pieces. You have this basically represents the way the program executes from start to finish. So it does a lot of the bookkeeping necessary to go from command line execution to actually processing the files. We also have the Jvm package over here, which deals with things like the class files, which are the output, of course, of this compiler. This basically represents a lot of the different magic numbers that are present in the class files. If you were to look at the specification, you would see that different parts of the class file are annotated with some numbers, like this is a field, this is a class, this is a string, so on. And so these are the different numbers that will be written into the class file, right? And of course, there's the ability to read and write class files. You can see, like, for example, including an integer, which is 4 bytes, requires that we decompose that integer into each of those bytes and then put them in the next 4 bytes of whatever buffer represents the output. There's the ability to write the attributes section. All of this is documented in the specification, and this shows how it's actually done in the official compiler, right? We have the file over here, which is an abstraction for the file system. And so you have things like the file manager and the ability to read zip files. That's interesting because you have you need to be able to look at jar files where you get a lot of information about what other classes are available to you during the compilation. And in order to do that, well, jar files are just zip files, and as a result, you'll need to be able to read zip files. And one more interesting thing that I found when I was doing this was this flags over here. Notice it's a class, but it has all these fields. That's what all of these little items are around the class. And if you look at them, they really look like it's some type of enum values, right? Yet flags is not an enum, it's a class. So it's an interesting design choice to use these types of fields. So that's an overview of the different parts of the Java compiler. It's not completely in-depth, but hopefully it gives you an example of the type of information we can extract from this kind of visualization and gives you a good high-level overview.